So water as a resource, one of the big things that we can talk about are what are called watersheds. So what is a watershed? Well, a watershed is like a conceptually useful for water budget studies. And what it is, it's the area where all of the water that is in it drains off to the same place. Okay, so that makes kind of sense. So here we are in a picture right here. All the water, any lands, it lands on the ground here on top of this ridge right here. It will, if it lands on this side of the ridge, it'll flow down here. If it lands over here, it'll flow to this river, and it'll all discharge at this one point here. Now, this on the other side of the ridge is in a different watershed because if it lands on that side, it's going to go to a different river. So everything within inside of this boundary right here is within inside of a watershed. So if you ever drive around the area, you'll see these signs that says you're entering the Elburn County watershed or this watershed. A lot of cities in the area like to post that you're in the watershed because that's kind of important, because say your drinking water supply is down over here. Well, whatever you do with inside of the watershed, that water is going to move towards that point here, and you could be contaminating it. So this is a watershed. Now, usually it's typically, and most of the time when we talk about watersheds, we're really talking about surface water. We're not talking about groundwater. While groundwater is part of this, the groundwater divide, we call it a groundwater divide, could be different than the surface water divide. Generally, they're the same because especially if you've got a ridge right in here, the groundwater flow at the goes from high to low elevation, so the groundwater will flow also to this point, but it doesn't have to. So this is generally a surface water or near groundwater surface issue, not so much an issue with groundwater. So watersheds, as John Wesley Powell said, that area of land, a bounded hydrologic system within which all living things are inexorably linked by their common water source, and where, as humans settle, simple logic demands that they become part of a community. So watersheds come in all sizes and shapes. They can be very large, they can be very small. They can, but one of the things is that they don't really follow municipalities, boundaries of states, countries. So we have boundary issues when it comes to watersheds. If we look at, say, like the Rio Grande, there's a lot of watersheds that go across the U.S.-Mexican border. We have watersheds that just doesn't end at a state line. So sometimes when we look at water issues and stuff, you're going to start noticing like right at a boundary of a state is like, oh, wait a second, that water doesn't cross state lines. No, it doesn't. It doesn't matter where you are. You're going to be in somebody's watershed, and you have to be careful because you could be impacting it. So a simple watershed is the topographic surface divide, assuming it coincides with the groundwater divide. Sometimes it does, sometimes it doesn't. It's a basin, and it defines the systems that you're in. So when we're talking about watersheds, and so you can define watersheds, there is a map I will post of all the major watersheds within inside of the state of Illinois. And so you can see that, depending on where you are, you may be in a different watershed versus a different one. So I'm going to make myself a note, Illinois watersheds. So we can be in different ones. So a lot of times we can also look at catchment basins. So right here would be the watershed right here, and then we could have these little watersheds, and this whole catchment basement contain all of these watersheds, and then it has one discharge point. So you can have small watersheds inside of a drainage basin area. So here's a watershed, here's a watershed, here's a watershed, but then we can have these bigger areas that get it. And a lot of times we use topographic control just because water is going to flow from the high to the low points. Now when we're in a state like Illinois where it's really not that much elevation, we still are elevation controlled. As you drive down the road, I would like for you to say, like, why is all of a sudden there's this like downward point on a road? So if you're ever traveling like on First Street in DeKalb here, and you're traveling along, all of a sudden it dips down and it goes back up, and you're like, why is that? Ah, there was a little river, something right there that's part of a watershed. So it does have some topography associated with it. And so we can see that generally groundwater is going to flow here. Now, groundwater could flow past these whole watershed basins. They don't, so it may be the shallow groundwater is associated with this watershed or this drainage basin, but we may actually have water that flows at different scales in there. So we'll talk more about groundwater coming up. Well, one of the first things we got to talk about with groundwater are wells. So if you live in a rural community, you will have a well. You'll have a well. It's in your front yard. If you live in the city of DeKalb, all of our water comes from groundwater, and it comes up a well. And so I want to talk about what is a well. So a well is a tube that intersects the groundwater. It's that simple. So you drill down into the ground, you'll hit that water table, which I already mentioned is, in this area about 3 to 6 feet below the surface. You will then have, you'll hit that water table, so you could have these really shallow wells. We call this like a water table well because it's intersecting the water table. You can also have wells that are very deep. So generally, and you're going to do an exercise based upon looking at wells in the state of Illinois. A lot of wells are about 100 to 200 feet deep. One of my friends who's located over in Maple Park has a 600-foot deep well. Our wells for the city of DeKalb are about 1,200 to 1,500 feet deep. So you can get very deep wells, shallow wells, that's all it is. And then you put a pump inside of the well and you pump the water up to the surface. And so like in this example here, what they did was before, this little well was here, and then they started pumping this big well. What they found was a cone of depression, they call it. So this draws the water down over here so they can water the field. And now all of a sudden the water table gets lowered down, and now these are dry wells, so there's no water in them. So that can happen. So that's the basics of a well. So what does a well look like? Well, here again, we have our well. Water comes into it. It's what's called a screen. I'll show some pictures coming up here. So the water table, as we pump water out, and we call this the discharge right here, as the water is being pumped in here, we're going to draw down the water around it, and we're going to form this cone of depression. So this would have been the original water table line, and then as this well is pumped, it lowers the water table right here, and then we form the cone of depression around it, and the pumping water gets into the borehole, and then we pump it up to the surface. So what does a well look like below the ground surface? This is just a typical schematic of it. So we have the ground surface. So this is the piece of PVC pipe. So it's just PVC pipe. It could be metal. It can be anywhere from, we can put in small wells that are like 2 inches to 4-inch wells to like the city of DeKalb at the surface. The well is about 16 inches in diameter. So they range in sizes. So depending on what you need. As I mentioned with aquifers, an aquifer is dependent upon the if it's usable source of water. So a small well will work for a small aquifer versus like what the city of DeKalb needs, which is a big well to feed all of the people. So you have this piece of PVC pipe that goes down. What we do is we put right here is between the borehole. So this is the borehole. So we drill a bigger hole and then we put a smaller pipe inside of it. Well, that smaller pipe in that borehole, there's what we call the annulus, or that area in between where the pipe and the ground is, and we fill that area in with concrete near the surface. So you can see here, this is all grout, or it's bentonite is also a clay seal, and so we can seal up this thing. So it's like cement that we cement in the top of it. Well, we don't want this moving. But more importantly, what we don't want is if it rains up at the top of the surface here, it goes down here, we spill some gasoline up here, it just goes right down into our aquifer. So we have to protect our aquifer from whatever we do at the surface. So we grout in all the way down to what we to the point where we call the screen, and I'll show you a screen in a second. So we have this protective layer on here. We'll usually have a cap on it. So if you see someone's homes, you'll see like a cap on top of their well so things don't fall in through the top. You'll also have protections there. So you'll have your electrical plumbing coming out. Usually with a well at a home, you'll have your pipe coming to your house. It'll be at a, below the frost line. You'll have your pipe coming into it, and the part you see at the top is access to the well and also the electrical that comes in. So the pipe is solid all the way down to where we want to bring in the water, so wherever the aquifer is. Then we put in a permeable, and we call it a well screen. Now, when I say screen, I'm talking something that looks like this. It's not like your screen for your windows, because I've had students make that mistake. They think it's like a screen for the windows, and it's not. What it does is this, you can see there's like these slits on top of it, and it holds the soil back from getting inside of it, so you don't get soil inside of your water or sediments or anything, and so the water can flow in but not the material around it. Now you notice one thing you notice about with the screen is that it's really gravelly right around the outside edge, and then the sand or whatever the aquifer material is out further, and that's done in purpose, because what we want is the water to flow easily into the screen so that we can bring it up. And so below ground we'll have this gravel pack right around the edge of the well screen, and so as groundwater is flowing in, it'll flow right into this. It'll keep particles out of the water. So we'll have that, and then we'll have that filter pack which I talked about around the gravel around there, and so groundwater can flow into it. So we have our well, our PVC pipe, we've got grout, we've got a screen, we've got what we call the annulus, which is that space in between them. We have a well screen in there, and one of the reasons that we have this well screen, as you can see here, here's the wire, here's inside the well, here's outside the well, that pushes water through. If we had small particles, they would flow into our water, and we don't want to drink pieces of dirt. So we build up these blockages with these bigger grains to keep all the smaller grains from getting inside of it. If you have a piece of PVC, we call it also slots. So here's the slot size. So these are the slots that are in it. You can have stainless steel ones, which cost a lot more than PVC pipe. PVC is a lot cheaper. You can have different types of metals that go inside of here, not just stainless steel. Stainless steel is nice for cleanliness purposes, because once you install these things, you don't want to pull them out. Just to give you a price cost for this, usually it's about $10,000 to put in a well for someone's home because of the time, the effort, the machines, everything that goes into it. I will be doing a whole lecture on installing wells, so you guys will learn a lot more about well installation because I think it's kind of important. Yeah, it is important. So what we do here is you can either have it where we live where there's sediment, but say you were going to go down to bedrock or solid rock, you may just have what's called an open borehole within inside of the rock. You might not even have a casing. So we call this the casing, is the metal part that goes outside of it is the casing. So it may be cased down to the edge of the rock, and then we may have an open borehole down to the bedrock, because this is not going to collapse. There's no sediment that's going to get inside of it. But we still have it grouted down to that point so that we're not getting any of this material getting into it. Now, if you don't grout the whole thing, you can have problems with contamination going in. You also don't want to screen the entire thing. You want to screen for that aquifer that you're interested in. So that could be your confined aquifer. It could be a very specific depth because you know the water is good. So we don't just open it all the way up so all the water gets in. Because as we talked about before, an unconfined aquifer, you can get a lot of pollution into it. It's what, you put stuff on your yard to keep your grass green. You don't want that getting into your water. So you want water that has gone through the soils and get into it later on. So those are some of the constructions of a well. Let me see if this will work. Move me out of the way. Let's see if this works. I'm going to pause it. So this video is just going to, or a little demonstration is going to show you what happens when we put in multiple wells. So especially with rural, we generally use more water rural situations than we do inside of the cities. We'll talk about urban water quality issues later on too, but DeKalb's in a rural area, and some of us do live on wells. So this is the water table. So notice this upside down triangle pointing to a blue line. This is our universal symbol for groundwater. So if you ever see me drawing a little upside down triangle somewhere with a line, that indicates where the water table is. So let's assume this is all clay, this is our sand aquifer down here, and we want to install a well. So we install a well over here. So here's our farmhouse and everything, and we've installed our well. Our water table went from here down to here because we're now pulling water from this aquifer here into our home, and it lowers the water table. Now let's say another farmer puts a well right into the exact same water table, the aquifer as us. It's going to lower that water table even more so down into there. So, well, actually, this is not the water table. This would be a potentiometric surface. We won't get into that into class, but just this idea that water levels will go down as you have more and more homes using that same aquifer. Now, when we get into it, like say we have all these little McMansions, you've seen them out in the countryside where there's these big homes. Well, each one of those has a well. Well, now all of a sudden we're really decreasing that water quality, that water levels, because of having homes so close together. So we really need to be able to know about how much groundwater do we have, what aquifers are we getting into, and information. So these are very local issues. And so when we look at this, this is the main issues when it comes to some of the rural stuff. So with that being said, I'm going to stop the lecture here. Keep in mind what a watershed is, aquifers, if you had any questions about that.